Okay, in this next part, we introduce summation notation. So summation notation is using the Greek S letter, which is sigma. And so when you see this notation right here, this means sum. So usually with this sigma notation, we have the sum, and this starts at a certain number. So this n can be 1, it can be 5, it can be 20, it can be any number that you start to plug into an expression over here. So let's say I had 3n minus 1. So this would mean that the first term is going to be found by plugging in this first number. So I could plug in 1. So this would be 3 times 1 minus 1. So the first term would be 2. To get the second term, you go up a number. So I could plug in 2. So if I plug in the next number, it's going to be 3 times 2 minus 1, which is 5. And you could keep going. So this index, what we call, could start at anything. It could start at n equals 7. So if it started at n equals 7, then the first term would be not plugging in 1, it would be plug in 7. So it would be 21 minus 1, which is 20. So that number can start anywhere. So what this summation notation means, you're going to add in the next numbers. So plug in 8, plug in 9, plug in 10, until you get the top number. So the top number is what is the last number that you're plugging in. So in this case, I would plug in 7, 8, 9, and I'd stop at 10. I'd plug 10 in. So I'm going to do a few examples of how I would write using this notation. So number 1, use summation notation. So what I do is I make a sigma, and it's for the first 50 terms. So I always start at 1 and go to 50. Then what I do is, using this pattern over here, using this pattern, I look at this sequence. So this is an arithmetic sequence. It's going up by 8. So I'm going to write the explicit formula for this sequence. So it's 8 plus n minus 1 times 8, because the common difference is 8. And then I simplify this. So this is going to be 8 plus 8n minus 8. So this turns out to be 8n. So my new formula, or my new summation notation, is written like that. Okay, now number 2, I'm going to repeat the same process. So it's telling me that n equals 6. So I'm going to go from n equals 1 to n equals 6. And again, this is an arithmetic sequence. So the sequence is going to be, the first term is 2, and the common difference is 2. So I'm going to distribute, not that 2 to here, but the 2 to here and here. So it's going to be 2 plus 2n minus 2, and that simplifies to be 2n. So that's how simple it can be to write in summation notation. Number 3, 9 terms. So it's going to be sigma n equals 1 to 9. In this case, my sequence is starting at 3, and it's going up by 5. So I'm going to simplify their explicit formula to be 5n minus 2. Sometimes I put it in parentheses just to make sure that you can see that this whole thing has a summation, so this negative 2 is not taken off. All right, then use the series, evaluate or find the number of terms in the series. So to find the number of terms, people mess this up a lot, is what you do is I would do 18 minus 1 and then add 1. Well, you might say, well, Mrs. Allen, isn't that stupid, because you can already tell there's 18. Well, if the numbers on the bottom is different, people have problems with that, which I'll show in a minute here. So the number of terms is going to be 18. So to evaluate the series, we're going to use the sum of the first n terms is n over 2 times a sub 1 plus a sub n. So we need the number of terms, which is 18 over 2. Now, to find the first term, you have to plug in the bottom number, which is 1. So the first term is negative 2 times 1 plus 3. So that's 1. And then the nth term, the last term, the 18th term, the 18th term is going to be negative 2 times 18, which is negative 36 plus 3. So it's going to be negative 33. So I'm going to add together 9, because 18 divided by 2, so it's 9 times negative 32. So it's negative 288. Okay, number 5, find the sum. Find the number, or for each sum, find the number of terms, the first term and the last term, and then evaluate it. So evaluate the series means get a final answer. So the number of terms is going to be 10 minus 1 plus 1. So the number of terms is going to be 10. The first term is going to be plug in this bottom number, and you get 1 minus 3, which is negative 2. To get the 10th term, you're going to plug in the top number, and 10 minus 3 is 7. So I'm going to use this formula, S sub 10 equals the number of terms over 2 plus the first term and the last term. So this is going to be 25. Number 6, find the number of terms. So I do 10 minus 5 plus 1. So I get 6. So it has 6 terms. So n equals 6. So it's going to be 6 over 2 times the first term. Don't plug in 1, plug in 5. So the first term is going to be half of 5, which is 2.5, plus the sixth term is going to be the last term. Plug in 10. So half of 10 plus 1 is 6. So I do, excuse me, so it's going to be 25.5. And then number 7, the number of terms is going to be 97 minus 38 plus 1. So 97 minus 38 plus 1 is 60. So n equals 60. So we're going to find the sum of the first 60 terms of the sequence. So it's going to be 60 over 2. The first term is not plugging in 1, it's plugging in 38. So do 3 times 38 minus 5, and I get 109. And the 60th term is plug in not 60, but plug in 97. So it's 3 times 97 minus 5, and you get 286. So it's going to be 30 times 109 plus 286. So the sum is going to be 11,850. So the reason that you have to add 1 is if you have the, I'll just do a simple summation. So if you have n equals 0 to 1, you're going to have to plug in, so a lot of people will just think, oh, that's just 1, there's one term. But actually you're plugging in 0 and 1. So there's actually 2 terms in that sequence. Same as if you had n equals 1 to 3. A lot of people, or n equals 0 to 3. A lot of people just think, oh, it's 3, but you have to plug in 0, 1, 2, and 3. So you always subtract these 2 and then add 1 to it. The number doesn't always have to start at 0 or 1. It could start out something different down here, like up here. So that's why you have to pay attention to that.